This is the sound of a new superpower being born. Not through armies or diplomatic treaties, but through sand and steel. In the middle of the South China Sea, China is constructing massive man-made islands, placing a powerful grip on one of the most important trade routes on Earth. To many people, it may look like piles of sand rising from the ocean. But in reality, it represents one of the most ambitious engineering operations of the modern age. The scale of the project is staggering. A transformation of shallow reefs into fortified islands that are reshaping global strategy. The story begins with a quiet presence on scattered reefs that had been contested for decades. For many years, China maintained only small outposts in this region. Then, in the early 2000s, a bold long-term strategy moved into action. The goal was simple but immense: construct permanent, unsinkable aircraft carriers in the sea. The chosen location was the Spratly Islands, a cluster of reefs and shoals claimed by several different nations, sitting directly at the crossroads of major global shipping lanes. The first challenge was not political or military, but geological. These reefs were made mostly of loose coral and sand rather than solid bedrock. Building heavy infrastructure on such unstable ground meant everything could easily wash away with waves or storms. The answer came in the form of an enormous fleet of dredging ships. Some of these vessels were as large as football fields and were among the most advanced dredgers ever built. At the center of the process were cutter suction dredgers. These machines functioned like giant underwater drills, combined with massive vacuum systems. Their rotating cutters ripped apart the seabed, while powerful pumps sucked up sand, coral, and sediment. Tens of thousands of tons of material could be extracted every hour. Instead of transporting mountains on land, these ships were effectively moving mountains from the bottom of the sea. The dredged material traveled through long floating pipelines, sometimes stretching for miles, until it reached the target reef. There the slurry was pumped out and spread across the shallow platform. The process was violent, chaotic, and astonishingly fast. Hour by hour, the original reef vanished beneath a growing mass of sand, while new land began to rise above the waterline. Freshly created land like this was extremely unstable. It was nothing more than soaked sand that could easily be washed away by the next powerful storm before any major construction could begin. Engineers had to build a protective barrier around the entire island. Massive concrete caissons were transported to the site. These hollow blocks were carefully positioned along the perimeter and then filled with sand and stone, sinking into place and locking together to form a solid defensive wall. Precision during this stage was critical. The perimeter wall served as the shield protecting billions of dollars of investment. Kilometer by kilometer, the fragile sand formation was wrapped inside a ring of concrete that held the sea at bay. With the island protected, engineers turned their attention to the ground itself. Water trapped within the sand had to be squeezed out through a process known as compaction. Heavy equipment compressed the saturated material again and again until the loose slurry hardened into stable ground, capable of supporting large structures. Continuous testing ensured the soil could bear the weight of what would soon rise above it. Once the land was stable, the next stage began. Construction crews moved in to build one of the largest coordinated infrastructure projects on Earth. The top priority was a runway stretching roughly 3 kilometers. long enough to handle virtually any aircraft in China's military fleet. A runway is far more complex than a strip of pavement. It consists of carefully layered materials designed to absorb the massive impact of heavy aircraft landing at high speed. Engineers created a foundation of compacted sand and crushed stone before pouring thick layers of reinforced concrete. Even the dredged sand was used to produce construction materials on site, reducing reliance on distant supply chains. The work continued nonstop, 24 hours a day under intense tropical heat. Hundreds of workers transformed what had once been an underwater reef into a perfectly engineered landing strip. When the runway was completed, its tolerances were extraordinary. Across the entire 3-kilometer length, the surface deviation was less than a centimeter, an incredible level of precision for such a remote construction site. The island was no longer just land rising from the sea. It had become a functioning airfield. Yet an airfield alone would be vulnerable to attack, so the next structures focused on protecting aircraft stationed there. Hardened aircraft shelters were constructed across the base. Each reinforced hangar was designed to withstand powerful explosions or missile strikes. Thick concrete layers and heavy blast doors turned every shelter into a miniature fortress. A full squadron of fighter jets could be hidden and protected inside these structures. With aircraft security in place, attention shifted to building the command center that would coordinate everything on the island. A command center required advanced sensors to monitor the surrounding skies and seas. Large radar domes rose above the base, their spherical shells protecting sensitive equipment from harsh weather, while allowing radar signals to pass through. From inside these domes, powerful radar systems scanned the horizon continuously. A single installation could track ships and aircraft moving hundreds of miles away. Specialized high-frequency radar arrays expanded that reach even further by bending signals over the curve of the Earth. These systems allowed operators to monitor activity far beyond the visible horizon, turning the island into a powerful surveillance platform. Collecting data was only the first step. Processing and distributing that information required a complex network of technology. Fiber optic cables linked every radar, building, and control station across the island. Beneath the surface, a protected data center housed powerful computing systems in climate-controlled chambers buried deep enough to survive direct attacks. Once the systems were activated, streams of data began flowing through the network. The island effectively woke up as a fully functioning command hub capable of tracking movements across vast sections of the South China Sea. Observation alone could not secure territory. The island also required defensive strength. Hidden beneath seemingly ordinary sections of concrete were vertical launch systems similar to those used on advanced naval warships. Inside these underground silos were missiles designed to intercept aircraft or strike hostile vessels hundreds of miles away. To an untrained observer, the launch areas appeared to be simple patches of reinforced ground. In reality, they concealed a powerful arsenal ready to deploy within seconds. The island had become both a surveillance station and a heavily armed fortress. Air power and missile defense were only part of the strategic plan. A deep water harbor was also necessary. Engineers dredged channels and reinforced the shoreline to create a port capable of handling large military vessels. The harbor was designed not just for supply ships, but for destroyers, heavy frigates, and potentially even aircraft carriers. With both an airfield and a naval port in the same location, sea power and air power could operate together from a single base. This combination transformed the artificial island into a critical strategic hub. Maintaining a permanent presence on such a remote outpost required more than military infrastructure. The island had to function like a self-sufficient town. Housing complexes, recreation areas, and support buildings were constructed to support hundreds of personnel stationed far from the mainland. Fresh water was one of the most essential resources. Desalination plants converted seawater into drinking water, producing hundreds of tons each day. Energy systems were built to ensure the base could operate even if supply lines were disrupted. Large solar arrays captured the intense tropical sunlight, while wind turbines added additional renewable energy. Backup diesel generators provided extra security. Together, these systems formed a resilient hybrid power grid capable of keeping the base operational at all times. Even small features played an important role. Sports courts, living spaces, and recreational facilities provided moments of normal life for troops living in isolation. These details helped maintain morale in an environment surrounded by open ocean. What began as scattered coral reefs had transformed into something entirely different. The chaotic construction site evolved into a carefully organized military settlement. Streets, buildings, and infrastructure followed a structured layout resembling the grid of a small city. An immense engineering effort had turned submerged reefs into fortified islands rising from the sea. Sand, concrete, technology, and strategy combined to create a new kind of outpost. One that reshaped both the landscape of the South China Sea and the balance of power across the region. This area serves as a parking apron for large transport aircraft. The vast stretch of tarmac was carefully divided into precise zones, each designed for specific aircraft types to ensure maximum logistical efficiency during rapid deployment operations. Every section of the airfield was planned with precision so that aircraft could move, refuel, and launch with minimal delay. A sophisticated hydrant refueling system was built directly beneath the airfield. Instead of relying on fuel trucks moving across the runway, aircraft can connect directly to underground fuel lines and refuel within minutes. Hidden beneath the runway lies a massive network of underground fuel storage depots capable of holding millions of gallons of highly volatile jet fuel, ensuring a constant supply for continuous air operations. Operating in the middle of the ocean introduces a powerful and unpredictable enemy: the weather. Tropical storms and typhoons regularly sweep across the region, bringing enormous amounts of rain in very short periods of time. A single typhoon can drop nearly a foot of rainfall in only a few hours. Without a powerful drainage system, the airfield would quickly flood and become completely unusable. Engineers designed an extensive drainage network to channel water away from the runway and surrounding facilities, allowing operations to continue even during extreme weather. To manage the complex movement of aircraft, a towering control center rises above the flat island landscape. This structure serves as the nerve center of the entire airfield. From inside the fortified tower, highly trained technicians coordinate the arrival and departure of military aircraft. The tower provides a direct line of sight communication link with approaching planes, allowing controllers to guide them safely to the runway. At the same time, construction crews completed massive barracks, complexes designed to house the growing number of personnel assigned to the island. These enormous concrete structures were built to accommodate hundreds and eventually thousands of soldiers and support staff. Inside, the living spaces are simple, functional, and highly efficient, built with practicality rather than comfort in mind. Supporting such a large garrison required extensive logistical planning. Industrial-scale kitchens were installed to prepare thousands of meals every single day without interruption. A fully equipped medical facility was also established on the island. The medical wing is capable of handling everything from routine illnesses and injuries to severe combat trauma, allowing personnel to receive treatment without leaving the base. The construction process followed a clear pattern. Engineers first ensured that the critical infrastructure was fully operational, then gradually expanded the supporting facilities around it. Once the runway surface had fully cured and stabilized, the next stage of testing began. Early testing relied on advanced unmanned systems. Sophisticated drones were launched into the surrounding airspace, flying repeated patterns above the island. These flights were used to calibrate radar systems, test communication networks, and ensure that every sensor across the island functioned perfectly. The drones gathered valuable data while engineers fine-tuned the technology that would control the airspace. After these systems were proven reliable, a major milestone arrived with the first manned flight landing on the runway. The aircraft chosen for this historic moment was not a high-performance fighter jet, but a heavy, dependable military transport plane. When the ramp lowered, and the first group of personnel marched onto the runway, the artificial island officially became a fully operational military outpost. A permanent air bridge now connected the remote base directly to the mainland. This new connection dramatically changed the island's logistics. Supplies, equipment, and personnel no longer had to rely solely on slow sea transport. Aircraft could deliver resources within hours instead of days. With the interior infrastructure secured, military engineers shifted their focus towards strengthening the island's outer defenses. A dense network of surveillance equipment was installed across the perimeter, feeding a continuous 360-degree view of the surrounding waters and skies back to the command center. Defensive weapons were added as the next layer of protection. Close-in weapon systems were installed around the island's perimeter. These automated radar-guided cannons represent the final line of defense, capable of firing thousands of rounds per minute. These systems are designed to destroy incoming threats, such as low-flying missiles or fast attack boats, before they can reach the island's walls. The island's defense strategy relies on multiple layers. Long-range missiles can engage threats far from the base. Medium-range weapons provide additional protection, and short-range automated cannons eliminate anything that manages to approach the island closely. The result is a tightly integrated defensive network covering every possible angle of attack. Soon after the defensive systems were installed, the true power of the base became visible when a heavy naval frigate entered the newly constructed harbor. As the ship secured itself to the deep water pier, the harbor demonstrated its true purpose. What had once been a shallow reef was now capable of supporting major warships. Naval vessels could dock, refuel, and rearm directly at the island, dramatically extending their operational range across the region. the coordination between naval ships, aircraft, and land-based systems created a seamless display of modern military logistics. Land, sea, and air forces now operated together from a single strategic platform in the middle of the ocean. In the final phase of construction, large landscaping efforts began across the island. These projects were designed to soften the harsh appearance of endless concrete structures. Trees, greenery, and recreational spaces were introduced in an attempt to transform the base into something resembling a small town rather than a purely military installation. The goal was permanence. The moment soldiers raised the national flag on the island carried powerful symbolism. The ceremony represented far more than a routine military tradition. It signaled a declaration of lasting presence and control. From the carefully painted sports courts to the neatly arranged streetlights, every element reflected a long-term deployment designed to endure for decades. To ensure that the island would never be isolated, engineers installed a large network of satellite communication dishes. These systems created a high-bandwidth communication lifeline, connecting the island directly to the mainland, even if other communication channels were disrupted. This satellite network would keep the base connected to command centers far away. In less than 2 intense years of construction, the project achieved something that once seemed impossible. A permanent, heavily armed strategic base had been manufactured in the middle of the sea. One of the most striking examples of this transformation is Fairy Cross Reef. What had once been a small, jagged reef barely visible above the waves had become one of the largest and most advanced island fortresses in the region. Several of these islands now form a strategic triangle across the Spratly Islands. Their radar systems and weapon platforms create overlapping zones of surveillance and defense. With these points connected, nearly every movement through this vital region of the South China Sea can be monitored. The arrival of naval patrols and Coast Guard vessels marked the beginning of a new reality. Ships from China's Navy and Coast Guard now regularly patrol the surrounding waters, enforcing territorial claims with a visible show of strength. These islands represent far more than land reclaimed from the sea. They function as powerful platforms for projecting military influence across the entire Southeast Asian region. From the reinforced runways and naval docks built on these artificial islands, China now has the ability to extend its military reach across vast distances. Before these bases existed, naval fleets operating in the region had limited range and required long supply routes. With this network of island outposts, the military now possesses a chain of forward bases that greatly expand operational capabilities. What began as an ambitious idea on paper has been transformed into reality using enormous amounts of sand, concrete, and advanced engineering.